Hello, everyone. My name is Yafeng Yin. I'm a professor and interim chair for the Department of Civil and Environmental Engineering, University of Michigan. So welcome to the University of Michigan Building the Future Distinguished Lecture Series. In 2019, our department completed a two-year strategic planning exercise through which we identify 5 strategic directions. So they are enhancing human habitat experience, adaptation, automation, smart infrastructure finance, and shaping resource flows, which is the topic of today's webinar. So this direction explores the analysis and control of resource flows within our habitat to minimize their negative impacts on the environment and public health while achieving equitable resource management. This is a very exciting focus for our department and the profession as a whole. Our strategic vision reaffirms our value proposition to our communities and reinforce our commitment as engineers working in service to society. And to highlight our vision and to formulate a work plan, so we launched this Building the Future Distinguished Lecture Series, which provide a forum to discuss each strategic directions. It's aimed to build a broad community network that include industry professionals, researchers, educators, and students through presentation from leading experts and panel discussions. So this series provides new insight and explore a range of perspective on these 5 strategic directions. So we have had a lot of support to make this vision and today's webinar come together. We would like to thank our co-sponsor for today's event, Office of Fossil Energy and Carbon Management, Department of Energy, Clayman Center, University of Pennsylvania, Penn Engineering, University of Pennsylvania, Global CO2 Initiative, University of Michigan, and Graham Sustainability Institute, University of Michigan. I would like to thank the Strategic Implementation Committee led by Professor San-Yung Lee. I also thank Professor Joshua Jack, who is assistant professor here at the University of Michigan. Professor Jack has agreed to serve as a moderator for today's presentation and panel discussion. So lastly, I would like to thank Joyce Kennedy, Michelle Santayam, and Mark Collier-Snyder for their technical and marketing support for today's event. A few more words about the accessibility of the webinar. We would like to make our event accessible to all participants. So the webinar will have a live automated captions and a transcript will be available. To choose a viewing options, please click the live transcript on the control bar at the bottom of your screen, where you can show or hide the subtitle or view the full transcript. I will now turn the session over to Professor Jack. Professor Jack, the floor is yours. You're on mute.
Thank you. Thank you, Yafeng. I would like to welcome everyone participating in today's event. Today's distinguished lecture emphasizes the strategic theme of shaping resource flows. To give an overview of this theme, I would like to play a 2-minute video.
Earth, and then after we're done with the resources, we would release it back out to the environment. We started to realize that a lot of those wastes that we would release have valuable resources in them. Civil engineers and environmental engineers were designing a lot of those flows. And so I think we have a big role to play in how we might continue to shift the mindset and think about, the future of what those flows might look like. One of the things I think we're doing that's really special is separating our wastewater right at the source, right at the toilet. And the reason that we're doing that is we can pull the nitrogen and the phosphorus out much easier before it's diluted in the wastewater, and then convert that nitrogen and phosphorus into really valuable fertilizer products. Researchers in CEE are building RECO blocks. These are blocks built out of materials from carbon that's been sequestered that are used to build structures. And then when the structures are done, rather than landfilling the material when we tear it down, we take those blocks and we use it in new buildings. Shaping the flows of these resources rather than a linear flow, we're making this a cyclical flow. In 50 years, if we're successful, this is just going to be in every activity we do as a civil and environmental engineer, how we're getting our resources, what we're doing with the resources, and where they go when we're done with them is going to be ingrained in our work.
Okay, excellent. Well, during the lecture and panel discussion, I will invite participants to send in your questions using the Q&A function on Zoom. We will try to get as many questions as time allows. Now I'd like to introduce our very special speaker and panelist. We are very fortunate to have Jennifer Wilcox, the Principal Deputy Assistant Secretary in the Office of Fossil Energy and Carbon Management at the DOE, who will speak to us on the role of carbon capture in meeting net zero carbon goals. The presentation by Jennifer will be followed by a panel discussion, and our distinguished panelists, Andres Clarence and Richard Middleton, will be joining that discussion. Andres is a professor of civil and environmental engineering at the University of Virginia and associate director of the Environmental Resilience Institute. Richard is a CEO of Carbon Solutions, LLC. This brings us to today's distinguished lecture. Let me now invite Jennifer to speak to this theme and give her presentation.
Great. Thank you so much, Josh. And thanks everybody for being here and sharing this time with me today. I'm really honored and excited to talk about the work that we're doing in the Office of Fossil Energy and Carbon Management, specifically looking at the role that carbon management will play in achieving net zero goals. And so just to get started, I wanted to kind of frame a little bit of the work that I'm going to be talking about today. And so you all know that we have in the new administration, in the Biden-Harris administration, that we have a net zero greenhouse gas goal of achieving net zero greenhouse gases by mid-century. And when we look at all of the sectors in this space and what are the tools that we have available from the carbon management perspective, how are we going to achieve this goal? And so what I'm going to talk about today is our investments and the efforts that we're making and looking at carbon capture and storage as we look at decarbonizing fossil fuels, but also looking at ways in which this tool can play a role in decarbonizing industrial sectors. That we can also look at even how we produce fuels today, and that the production of fuels comes with emissions. And so looking at quantification and mitigation of, say, methane associated with fossil fuel production. And then finally, recognizing that in order to achieve net zero, we need carbon dioxide removal to counterbalance the hard to decarbonize sectors to achieving net zero. And so I'm going to talk a little bit too about that critical tool of carbon dioxide removal. And really in the Office of Fossil Energy and Carbon Management, we're investing across these different strategies in order for us to achieve greenhouse gas emissions reduction and net zero by 2050. And I started in the administration on day one, January 20th, almost 2 years ago now. And in my role at the time as acting Assistant Secretary of Fossil Energy and Carbon Management, we really took a step back in terms of the investments that the office had been making previously and historically, and we spent a year reorganizing the office. And one of the aspects that we updated is adding the two critical words, carbon management, to fossil energy. And the other piece is that we really flipped the mission upside down. And so previously, the mission of fossil energy was really about how can we get more fossil fuels out of the earth? How can we do that cheaper and faster? And really what we did in the reorganization is, as we recognize our dependence on fossil fuels, how can we make sure that we're investing in strategies that minimize our climate and environmental impacts on that dependence? And so looking at the portfolio investments that we're making in FECM, ensuring that all of those investments are helping us to achieve the different goals of the administration. I mentioned net zero greenhouse gases by 2050, but in order for us to do that in time, there's two critical tools along the way, or two critical goals along the way. First being 50% emissions reduction by 2030, which is less than a decade away, and then CO2 emissions-free power by 2035. And when we look at our dependence on the right-hand side of that pie, the question is as we invest in carbon management tools, how can we really shrink each of those pieces of the pie? And so we took a step back too and started to think about a strategic vision within our office. And in order to figure out where we needed to invest across the different areas and recognizing that our investments were associated with R&D, thinking about, well, how are we dependent on natural gas today? How are we dependent upon oil? And how are we dependent upon coal? And so the top bar of each of these is really our energy consumption and net exports. And then the bottom bar is the corresponding greenhouse gas emissions. And you can see the different colors are the sectors. So blue being commercial and residential heat, orange being industrial heat. You can see green in the transportation sector, and then electric power in red. There's also a really important piece here, which is the gray box with a question mark. And what that is I mentioned it earlier, but when we extract natural gas, oil, and coal out of the earth, there's also methane emissions associated. And it's really unclear exactly the quantification of how much methane is emitted from the production of fossil fuels. And so in our realignment of our office, we enhanced this program significantly to make sure that we could invest in strategies to improve the quantification and transparency of these emissions, and working closely with the Environmental Protection Agency as well as it couples to the regulatory body of mitigating methane. And so that's a big part of our program. But when we also look at the different other sectors and how we're dependent, with natural gas, it's the most complicated. We're dependent upon it in a lot of different ways, for heating our homes to powering everything that we have that we're dependent upon in terms of power. And so you're going to also see in my talk today, when we think about carbon capture and retrofits, carbon capture on power plants is also significant, and also recognizing that the fleet in terms of natural gas is younger than the fleet of, say, coal-fired power plants. And that if we're to achieve net zero, we need to make sure that we have the ability to decarbonize committed infrastructure that's going to be persisting through mid-century. When we look at our dependence upon oil, you notice the heavy dependence in the transportation sector. And what we're focusing on are hard to decarbonize sectors. There's a lot of momentum in terms of passenger vehicles and electrification. And so we're more interested in thinking about other sectors like long haul trucking, shipping, and also aviation. And here we're really focused on using CO2 as a chemical feedstock combined with clean hydrogen to produce synthetic fuels and chemicals. And then again, as we look at the power sector, that's where we're dependent upon coal still. And so I'm going to talk to you a little bit too about the recent legislation that's passed. But if you want to learn a little bit more about our strategic vision, we published this in April last year. And it's really about the investments in our office in FECM, and not just associated with reducing the carbon pollution, but also associated with the legacy, environmental, and climate impacts of how we extract fossil fuels out of the earth today. And then finally, advancing justice, labor, and engagement, which I'll talk a little bit more about in my presentation. And so also wanted to point out that when we look at the carbon capture program and the investments, thinking about lab and bench, all the way through technological readiness levels of 4 to 5 and 5 to 7 up to large pilots and front-end engineering design studies, we recognize that there's a lot of options out there today that have already been tested for point source capture. And so what we're focusing on is less of the lab and bench and more higher TRL and more feed studies. Feed studies are the first step to being able to really carry out a successful demonstration. And recognizing that not a lot of attention has been paid to the industrial sectors. And so looking at trying to invest across a very broad portfolio of the different industrial sectors, whether it's cement or steel production or pulp and paper. And so trying to do more of that work. In addition, we want to try and push some of the separation technologies to achieve higher efficiencies in terms of capture, greater than 95%. Another key element is recognizing that when you retrofit existing plants, whether it's a power plant or industrial facility with carbon capture, that you're enabling that feedstock, whether it's the fossil fuel that's going into the plant or the emissions associated with what you might be producing, like cement. But what we're trying to do is recognizing that there's pollutants outside of greenhouse gases. So for instance, there could be, if you have a cement plant and they're using a fuel like coal or waste tires, there's all kinds of different feedstocks that go into the cement kilns. And recognizing that as we develop the carbon capture technology, that you're really capturing an acid gas, and that if you're capturing CO2, you have the opportunity to capture other acid gases like SOx, NOx, and also even decreasing particulate matter. So what we're really requiring of every dollar that goes out the door associated with these carbon capture technologies and approaches is that there's recognition in terms of the monitoring of co-pollutants, and that as we're designing technologies and retrofitting plants, that we're also monitoring and capturing the other co-pollutants where we can, and being very transparent about that data. In terms of the recent legislation that's passed, I just want to mention a little bit of this. So two key pieces. There's the bipartisan infrastructure law, which was passed about a year ago. And in terms of carbon management provisions, about $12 billion over the next 5 years to build out the first of a kind projects. And we really have an opportunity not just to create gold standard projects in terms of de-risking technology, but also the social risks. And I'm going to talk a little bit about that in just a minute. But before I get there, I also want to talk about the other piece of legislation that's passed, the Inflation Reduction Act. It's really critical that we have these two pieces. So the bipartisan infrastructure law is all about building the first of a kind, expensive first of a kind capital. But if we're really to achieve these targets that we're setting out in terms of the role that carbon management will play across these different approaches, we also need to recognize that the private sector needs to be able to invest in the second, third, and fourth, and ultimately nth of a kind. And so the Inflation Reduction Act and the 45Q federal tax credits and their increase is significant, and it's really critical for us to have all the pieces of the puzzle that we need to get to the scale that's going to be required. And so for point source capture, it's been bumped up to $85 per ton of CO2 coupled to dedicated storage. And for direct air capture, it's been bumped up to $180. With also, there's different minimums in terms of project size, 1,000 for direct air capture, roughly 12,000 for industrial, and roughly 18,000 for the power sector. So these have all been lowered so that we have more facilities, more units that can qualify for the federal tax credit. In addition, we've also done a lot of work in our team at FECM, and really want to give thanks to Holly Jean Buck for a lot of the effort. And we brought her in to work on this in terms of the equity and injustice components. And you can see a link there if you want to learn more about the engagement work. You can take a look at our website. But when we look at all of the carbon management projects, we're really looking at advancing equity and justice for communities. And in fact, not just within FECM, but also all of the infrastructure law funding. And it was $62 billion for the Department of Energy. So all of the infrastructure law funding will come with, as the Secretary likes to say, strings attached. So I'm going to describe those a little bit. So project applications will require 4 key elements, and it's ultimately, at the end of the day, a community benefits plan. And the 4 key elements to that plan require community and stakeholder engagement, diversity, equity, and inclusion and accessibility, and also the Justice 40 initiative, which has to do with the fact that as we make investments, that roughly 40% of or the benefits will be received by 40% and allocated to disadvantaged communities. And then finally, quality jobs. So these 4 critical elements will be part of the community benefits plan. And at the end of the process, it's weighted by 20% of the proposals. And so it's a pretty significant component. And as we've also been working on this, and I've done some work as well in terms of just engagement and outreach, one of the biggest barriers associated with CCS that I'm seeing, and it's not just CCS, but also carbon, some of the aspects of carbon removal, is being able to put CO2 in the ground and really being able to see Class 6 permits move through. And so this is something that I've been working really closely with in our office in FECM and also with EPA. And part of the key is being able to teach communities that we have the expertise, that we've invested over 2 decades at the Department of Energy in developing the tools to monitor CO2 in the subsurface, and that we have expertise. And in fact, through the Recovery Act days in the Obama administration, we had 3 successful demonstrations where we were able to store roughly 12 million tons of CO2, and since 2013. And so really being transparent about what the risks are and that we have the tools to get ahead of potential problems, and that EPA regulations are set to rigorously prevent leakage into groundwater, and also preventing seismic events. And so this work is really critical as we're trying to move these projects forward. I also mentioned that as we look at CCS specifically to the power sector, especially natural gas and in sometimes coal as well, when we mine coal out of the earth, there can also be methane emissions, but mostly with oil and gas production. And so our office is expanded significantly in the area of quantifying methane associated with production of fossil fuels, but also investing in the technologies so that industry has available the opportunity to deploy technologies to mitigate their emissions. And so a lot of work associated all across from the production through midstream, and then of course downstream, as I mentioned with CCS on power. The other piece I wanted to mention that doesn't always get a lot of attention is our work in critical minerals and rare earth elements. And this actually, when I saw the video that, the 2-minute video at the beginning, I thought of this work a lot in terms of shaping flows and supply chains. And so as we look at the legacy impacts of fossil fuel production, and here I'm specifically talking about coal production, we recognize that the legacy impacts are examples like acid mine drainage, fly ash impoundments, mine tailing waste, and that these wastes are in communities and they're impacting ecosystems. And we actually have an opportunity here to be able to carry out separation processes with these unconventional resources. And so here, this is showing 4 pilots that we have across the US, in West Virginia, also Kentucky, North Dakota, and Western Pennsylvania, where we're looking at unconventional sources associated with the coal industry and the opportunity to extract critical minerals and rare earth elements, which are going to be essential for meeting our clean energy targets in terms of EV motors, in terms of magnets for wind turbines, and the list goes on. And there was a nice article that came out. The author was Eliza Griswold, and she visited one of our pilots in West Virginia and went on an 18-mile bike ride and got to see all of the work that's being done there on cleaning up acid mine drainage and restoring that landscape. And if you're interested, I encourage you to take a look at the New Yorker article that was published on this work. And she's an amazing author, so it's a nice story. In terms of also, just thinking about overall accelerating the carbon management and everything that the legislation that I pointed out, both the infrastructure law and the IRA have, it's for carbon management over $12 billion over 5 years in grants, loans, and credits. What we're expected to see with these investments over the next 5 years, 6 carbon capture integrated demonstration projects, several pilots as well, but those 6, 4 will be associated with the power sector, 2 associated with the industrial sector, and then also 4 direct air capture hubs, ultimately looking at $2.5 billion of investment to expand the storage infrastructure of geologic storage of CO2. What we're expecting is 100+ new dedicated CO2 storage wells and actually getting to a capacity of 60 million tons of CO2 injection per year. And again, this is all outlined in our strategic vision. And then today in the United States, we have about 5,000 miles of CO2 pipeline. And FECM, in collaboration with the Loan Programs Office and Jigar Shah and his team and at DOE, will be doubling that to 10,000 miles and moving tens of millions of tons of CO2 per year. And then I'm going to talk a little bit too about the other tool. I've mostly talked about carbon capture, so avoiding CO2 emissions from entering the atmosphere to begin with. And I talked a little bit about this is a critical tool, carbon removal, to achieving net zero greenhouse gas emissions. So carbon removal in the near term is going to be a critical tool to help us counterbalance the hard to decarbonize sectors today, like agriculture, some parts of the transportation sector. And it's just important to recognize that carbon removal is a different tool than point source carbon capture. They are different designs. They require different land and energy requirements. Water requirements may differ, and that these are 2 very different tools. And when we think responsibly about how much carbon removal, I like to do the bottom-up calculation. And the bottom-up calculation, if you look at the United States and just based on 2019 emissions data, and the truly hard to decarbonize, hard to abate emissions, you can see here when you add up agriculture, long-haul trucking, aviation, shipping, and some residual emissions associated with not being able to capture 100% at a power plant, or not being able to completely mitigate methane from production of the fossil fuels we're still dependent upon, even in a net zero world. You do that bottom-up calculation and you're still just over a gigaton. And so the key is if this is truly going to be in our toolkit by mid-century to achieve net zero by mid-century, we've got to scale up to on the order of thousands of tons of removal per year to a gigaton, and that's 6 zeros in 28 years. And so we have to be able to invest in carbon removal to get it to the scale required, in addition to deep decarbonization. And so what we've also launched, this was at COP last year, is the carbon negative shot. And so this is actually across all approaches to carbon removal, what are called nature-based approaches and accelerating nature's uptake and, say, improved forest management, improved soil carbon storage, and then also the more engineered or chemical engineering based ones like direct air capture or mineralization. And we really used the National Academy of Sciences reports as blueprints for developing the carbon negative shot, which isn't just FACM, it's all across Department of Energy, where we're looking at annual appropriated dollars and collaborating and combining them so that we can invest broadly across carbon removal to be able to ultimately, at the end of the day, arrive at durable and scalable carbon removal at a cost of around $100 per ton. And the key to this, and you'll see we put out a notice of intent a couple of weeks ago, is really getting the monitoring, the reporting, and the verification updated, correct, and standardized potentially across some of these approaches where it's not as robust as, say, a Class 6 permit from EPA that's coupled to the monitoring, reporting, and verification. We need that kind of, standardization and high quality in terms of carbon accounting across all of the approaches. And then I'll just end in a couple of slides here, highlighting the infrastructure law dollars, really looking at $3.5 billion associated with direct air capture hubs. We also have commercial prize at $100 million that'll be coming out, and then pre-commercial at $15 million of prize funding coming out. I mentioned $2.5 billion for storage and validation, and really building that out to 60 million tons of CO2 injection per year in terms of building out the capacity so that when you start to look at developers and doing carbon capture, that work can be enabled because there's a place for the CO2 to go. So really the government helping to pay for the capacity of geologic storage, 310 million towards carbon conversion. It could be to products, as we heard about in the video, like CO2 or carbon converted and stored in concrete or building materials, but really looking at approaches that maximize the climate impacts and benefits. Front-end engineering design studies at $100 million. Those are mostly associated with the infrastructure for transport. I mentioned the critical minerals and rare earth elements, and I showed you the 4 pilots. And so we actually in the infrastructure law have $140 million to help to pay for one of the first kind demonstrations of starting those unconventional resources and the significant co-benefit of cleaning up ecosystems and bringing value to communities. And then also in 2021, about a year ago, Department of Energy broadly realigned and started a new undersecretary for infrastructure and brought in the Office of Clean Energy demonstrations, where we're going to see a lot of these dollars go through the door of these large projects, like the hydrogen hubs, for instance, and also the integrated carbon capture demonstrations and large pilots that I talked about. And then, of course, our collaboration with the Loan Programs Office as well. So a lot of exciting work happening in the carbon management space. And for more resources, you can take a look at the links here if you're interested. And thank you so much for having me here today. And I'm excited to be part of the panel discussion.
Thank you so much, Jennifer, for that amazing and inspiring talk. The carbon management techniques that you described are right in line with the strategic directions we have focusing on shaping resource flows. So it was a pleasure to hear you talk on that. Right now, I'd like to open up the floor for our Q&A. And before I don't see any in the chat right now, so I can get the ball rolling with a question. So we touched a little bit on direct air capture. And so I was wondering, for a given amount of low carbon energy, as some of these DAC technologies can be pretty energy intensive, when does it really make sense to use that low carbon energy for DAC technologies to maybe achieve 99% purity CO2 stream that you can then store, versus directly using that low carbon energy to decarbonize power off the grid by abating fossil fuel use?
Yeah, and that's why I tried to have that slide of these two very different tools. And so when we think about prioritizing low carbon energy, I think it always should be prioritized in a way to displace, say, a retiring fossil fuel fired power plant. So that opportunity to decarbonize should always be first and foremost. But I also want to try to pull away the misconception. I know that direct air capture is very energy intensive, but at the same time, there are creative approaches that we can think about. And so not all the time do you have to concentrate the CO2 to 99% plus purity, transport it in a pipeline and put it underground. You could co-locate with, say, an alkaline source like calcium or magnesium. And it's not clear how pure that CO2 has to be a reactive feedstock for alkalinity to make a synthetic carbonate, which could be used for building. And so maybe you only need to concentrate it to 30%, and that dilution of nitrogen is okay. And so I think there's ways to think about it. The other piece is like, there's also differing direct air capture technologies out there. Some use a very, very strong binding base, like potassium hydroxide, for instance, but others can use like solid sorbents with a weaker bases like amines. And so those solid sorbents, the quality of heat is much lower. And so it could be that you could couple to say, the heat coming from a geothermal power plant before it goes into a condensing unit and is injected underground, you could actually feed it into regeneration for direct air capture. And so we actually have front-end engineering design studies where we have funded 4 different feeds associated with coupling existing utilities to direct air capture like geothermal. Another example is nuclear. And so in nuclear, there's sometimes stranded electrons that aren't always able to go to the grid. And so it could be in that case that you're using those electrons to couple to direct air capture. And at the end of the day, in both of those scenarios, you can produce carbon negative power.
Excellent. Yeah, thanks. I agree a lot with what you said, and thank you for laying that out so nicely for everyone here. We do have a question in the chat that's sort of related to some of the nuclear that you described. It says, please speak to the viability and feasibility of modular nuclear.
Well, I will say I am not Katie Huff, and I am not a nuclear engineer. I'm a chemical engineer. And so, I'm in support of a portfolio, including modular nuclear, small modular reactors. And I see too, just from my perspective at DOE, that there is a shift and you're seeing some of the retiring coal-fired power plants and utilities switching to small modular nuclear. And I think it's interesting. I think that, again, it's part of the portfolio, but that's not my expertise. And I would lean on nuclear folks more for that.
Right. Yeah. One question maybe for the panel is, you spoke on some of the challenges already, but what really are the major challenges that exist when you're trying to integrate some of these CCS technologies with existing utilities? And anyone can start, I guess.
Yeah, we've got to welcome our other panel members here. Yeah, Richard and Andres.
Yeah. Maybe Richard, would you like to start on that?
Yeah, I was really hoping Andres would turn his camera on first and then you'd pick on him. I don't know if I have a specific great answer. My general feeling is, I worked in the National Lab System for 15 years. We started a company a couple of years ago, and it's amazing how industry, including utilities, is really trying to push forward. They're not holding back. They're making internal investments. They're rating FOAs. I mean, the thing I've learned in the last year is a lot of industry want to respond to DOE calls. They don't know how to do it, and so we're helping them. There's just a lot of activity, and they are moving forward. And so, you know, I know the single biggest thing for utilities, and this in general, I think, and Jennifer kind of talked about this, is, you know, we have to scale up very, very quickly to get to, you know, 50% by reduction by 2030, decarbonized electricity by 2035, decarbonized economy by 2050. The scale up is massive. And so, you know, I think it's whatever we can do to make this happen is really important. But I guess my point is industry is really behind this. They see it, they want help, and now part of the challenge isn't trying to convince people quite as much as how do we get this going at the rate we need.
Great. Yeah, I guess maybe a follow-up question for you is maybe in what areas do you see advanced software and data analytics having a big role in accelerating decarbonization?
Well, as a software and data analytics company, of course, my answer is going to be we see a big role. Again, I think there's just so many ways that people need help. And so we're trying to do our little piece of helping, you know, for our company's really about, can we accelerate people through the decision space right at the beginning? We're not going to help put steel in the ground. Can we help educate people? How can we make them aware of the issues? How can we do the feasibility studies to kind of encourage them to make the investment? And so for us, that's what we're focused on a lot. You know, and a lot of companies, once they've jumped in and they're making the investment, maybe they don't need quite so much help with the software and the data analytics. But I think there are so many companies out there that are interested, and I do think it's a way for them to, you know, to bring them to the table, get them to understand the problem. You know, one of the things we hear a lot is we speak to a lot of interested people, but they have to go back to the board of the company, or they have to go back to investors and convince them that this is a thing that they should invest in. And so I think that's another area that we can really help with. Anything we can do with screening and education and move them along, because I think once they're ready to go, these companies are often very committed. They have amazing people, they have investment, they'll do it. And so sometimes, you know, I feel like they almost need to push at the beginning. And so, you know, some of it is, I mean, Jennifer talked about all the amazing things DOE is doing. I mean, they're big numbers, right? We've never seen these numbers before, and that is absolutely amazing. And there's a lot of people are ready to jump in. I mean, like, you know, something like the direct air capture hubs, I don't know what's going to happen. But, you know, if you go back a year, people say, oh, well, there's only 2 companies that can apply for that. What are they, you know, what's going on? And today, I don't know, I think dozens of people are interested. They see it, they're moving along. The one thing that I think still could be good is, I think, you know, DOE's done a great job investing in. Now we're moving on to phase 2 and 3 and 4 projects. There's actually some companies out there, a lot of companies that would still appreciate phase 1 projects. As in, you'd be surprised at how many utilities are interested, but they haven't done anything. And so they almost need that beginning help of, hey, can you, you know, somebody lower at the company, can you help us invest in this? Then if we do this, we can convince the higher ups of the company we can do this. They do big projects, right? You know, in the 80s and the 90s, cleaning up pollution. Utilities know how to do big projects, but some of them still, I think, need some help getting off of that first level. And so it's good, you know, once you see, you know, that the FOA is out right now for phase 3 and phase 4 projects, that's amazing. People are doing this, but there is a whole group of companies out there that we've talked with that are probably at the phase 1 level. Maybe they feel like they're getting a little bit left behind.
Okay, great. I actually have a pre-submitted question that might fit into this conversation well. It says, what lessons has the DOE learned from how it's funded previous demonstration projects in the past? So maybe.
Sure. Yeah, that sounds like that one might be towards me.
Yeah.
Yeah, so definitely there are lessons learned through the Recovery Act days. I think, you know, there is a GAO report, and you can take a look at that to better understand too, you know, the details. But at the end of the day, when you look at those investments and you look at the ones that were successful, and an example is, the Air Products project that we have in Port Arthur, Texas. Another one is in ADM, which is coupled to a Class 6 well in the Mount Simon Sandstone. And then the third one, technically, from a technology perspective and a carbon capture perspective, was the Petra Nova project. And when you look at, bioethanol, well, there wasn't a lot of R&D required there because the CO2 comes out at the fermentation process of 99% plus purity. So it's pretty, it's not a hard separation there. And so it's kind of no surprise that that was successful. The harder part of it was that Class 6 permit coupled to geologic storage. It was that integrated, component of the capture and the storage that made that difficult. And so showing that success, and that was the images that I showed in my presentation too. In terms of Air Products, when you look at hydrogen production from natural gas, that's also a higher purity, not 99, but it's 45% or so. So again, it's easier to separate. And now carbon and nitrogen, that's where we've been actually working in that space of separations for a long time. The projects that weren't successful were gasification projects. And that's really, it was a different type of separation, CO2 or CO and hydrogen, but also at the same time as developing the technology for the separation in that gasification process was developing and scaling up gasification itself from coal at that time. And so it was like you're investing in the scale up of a technology and investing in the carbon capture technology all at the same time. Those did not show so much success, and there were new builds, which kept meaning more and more dollars were invested, and there wasn't a whole lot to show at the end of the day. And so one thing I'll say with the infrastructure law funding that's different this time around, and back to the lessons learned, is that we're talking about retrofits, and we're talking mostly post-combustion. So that means nitrogen and CO2 mixtures. When you're looking at cement, when you're looking at some steel, and when you're looking at power sectors, whether it's coal or natural gas, these are broadly mixtures of nitrogen and carbon dioxide, which we did successfully. And so I think that's, where we can learn from and feel good about de-risking the 6 investments that I mentioned with the integrated CCS demonstrations. Direct air capture and the hubs, that's different, but I think what we have going for us isn't just the infrastructure law funding. It's the IRA, it's a 45Q bump up. There's that additional incentive. And then there's even the voluntary market today and a recognition that carbon removal is critical. And so we see a voluntary market and investments. There's just a lot of energy in that space. And so I think it's going to be really important that, and I think, Josh, you mentioned this, just the broad portfolio of companies that are coming online. It's not just 2 anymore. There's a lot of exciting technologies out there, and it's really important, I think, and what we're going to try and do is meet the industry where it's needed. And Richard, you mentioned too, of it was industry maybe in power sector feeling left behind, but we don't want that to happen for this new emerging group in terms of direct air capture. So.
Yeah, I mean, it seems like there's a great environment here in the U.S. with the policy and the market here to sort of tackle this issue. One question that was pre-submitted that may come in to the conversation is, how is the U.S. working with the rest of the world to reach net zero carbon emissions? And then how realistic and practical are those plans? I think that probably is directed towards you, Jennifer.
Yeah, I can keep talking.
Yeah, sorry.
Yeah, I'm a professor on leave, so I know how to profess, it turns out. But with that, I mean, I think, what we're doing, we have our mission innovation, that we are really engaging with Canada, Norway, Europe, Japan, and trying to get a broad group of global stakeholders interested in carbon removal and its scale up. And recently at COP, the secretary announced the CDR Launchpad, where we're really trying to get the partnerships of these other nations to commit to thousands of tons of carbon removal. And the other piece I think that that's important that I should mention is the transparency of data and the lessons learned. And as we're investing in projects, making sure that as much as we can, that the failures and the wins, that we can share that information so that when approaches are tested at the second or third of a kind, that the lessons learned can be adopted in that second and third of a kind aren't making those same mistakes. And so it's going to be really important that there's a transparency associated with the outcomes of the investments.
Yeah, one thing I see as being a big way of accelerating decarbonization is actually taking things like CO2 and turning those into valuable fuels and chemicals. CO2 valorization could really accelerate this space. Maybe I'll ask Dr. Clarence. I know you've had some work related to carbon negative cement materials. So what are the bottlenecks in really deploying some of these carbon negative cement materials?
Thanks for the question, Jack, and it's great to be back in Ann Arbor, sort of. Yeah, that's a great question. I think it's a really important question, particularly for civil engineers, right? Because a lot of what Jen's talking about, if you're talking about gasification, or you're talking about fuels, are questions that chemical engineers tend to explore. But you know, when we talk about materials that are climatically relevant, meaning that we make enough of them that if we could incorporate CO2 into them, they would actually make a dent in our overall carbon budget. There are a number of materials that civil and environmental engineers engage with, and one of the most prominent is cement, which is 8 or 9% of global CO2 emissions. And there are ways, traditionally, carbonation of cements has not been viewed as a good thing, but there are alternative chemistries that different research groups are exploring that can actually strengthen the materials if you carbonate them. And so our group is doing some work in that space. In the video we saw earlier from Krista, there were pictures of Victor Lee, and he's been doing a lot of this work for a long time. The challenges there are both, in the conversations earlier, we talked about carbon capture as being a coupled thing, right? You got to get the CO2 somehow, and then you got to put it into someplace somehow. I absolutely think that really trying to maximize all the places where there are co-benefits, meaning you can sell a product, means you're going to have adoption sooner than if we're just disposing of it. So the circular economy themes that came out in the video we watched at the beginning are totally a thing that excites me, and I think that you're going to see earlier adoption rather than just having to pay to dispose of it. And so I think in the context of cement, I think that there is an industry that is got bottlenecks around regulation. So local regulation around building materials, local building codes. What can you use? What can you not use? And those are there for a reason, which is we want to protect people. We don't want to build buildings out of anything that could then collapse. And so we have to understand the role policy plays. We have to understand the role that the building industry plays, right? That masons play in the materials, how they use them, how they interact with them. At some stages, people are not super willing to try out new things, right? And so we have to get through some of that. And then at the sort of manufacturing stage, a lot of these materials are actually cured or precast, which is great. And that sector of the industry is growing, but getting the CO2 to these facilities is not trivial. And so a lot of the infrastructure that Jen talked about earlier is really critical, but we have partnerships with big infrastructure materials firms, and they will always, one of their first questions out of their mouth is like, okay, if we could do this, we just operate on scales that for many of us in the academic realm is hard to think about. If you're producing just enormous quantities of concrete blocks, for example, getting enough CO2 to one of these facilities is a non-trivial proposition. And so, that's an example of a bottleneck, an infrastructure bottleneck that I think we're gonna begin overcoming, but it's going to take some time.
Excellent. Yeah. So sort of on the CO2 valorization type theme, I have a question here in the chat, and it's asking basically what you all think about using off-peak power to synthesize carbon fuels using CO2 reduction after it has been collected from DAC or another process.
I mean, I can start. I would just always say, you got to make sure you know where the hydrogen's coming from. In synthetic fuels, that's going to be a key piece. And if it's green hydrogen, the electrons required to do that are significant. And so you really just have to kind of look at that balance at the end of the day of what's going to be required to not just capture the CO2, whether it's from the atmosphere or from a point source, but what's required to produce the hydrogen. And then what's required to actually react the two, to reduce carbon dioxide so that it's in a reactive state, and then to react it with hydrogen to then make the fuel or chemical that's desired. And so it sounds so easy to just use off-peak electricity to do this, but it's like just, recognizing that there's a lot of resources that go into that equation.
Great. Okay. So I guess I have a broader question. So I often think about sort of how those who are emitting the most amount of greenhouse gases are not geographically located next to those who may potentially feel those impacts, maybe the global north versus the global south. And thinking about, sort of equity and justice, how do we sort of reconcile those sort of disparities between those who are emitting a lot of the CO2 and then those who are feeling sort of the harmful effects of climate change? And how do we think about and while we make our carbon management plan?
Yeah. Oh, do you want to go, Andres?
Anyone, yeah.
Go ahead, Richard.
Well, I should say something great. So I think it's a good question. And, we have a small project with DOE that we're working on right now that's getting at this just a little bit. I mean, when it comes to things like environmental justice and energy equity, I think the most we can hope to do as small companies and universities, like just keep chipping away at it. One of them is what we've really started to look at is how to collect information from underrepresented or underserved or disadvantaged communities. One of the ways is in the sense, kind of what you were getting at, Jack, is that climate change for these communities is often not their biggest concern. It's probably not in their top 5 or 10 concerns. It just isn't. And that's kind of clear when if you're doing surveys, you talk to the communities. But there can be a lot in common with this. So, our project is looking at hydrogen and, using hydrogen for fuel and feedstock switching. And looking at best places to do that. And it's similar to where you might put CO2 capture, but it's really looking at what are actually the co-benefits that the community might really be interested in. So I think they're very interested in good paying jobs, and they're very interested in reducing environmental pollution. So air and water, other environmental pollution. And it's really important. But the idea is, I think you can co-optimize both things at the same time, decarbonizing industry. And, when Jennifer was talking about Justice 40 and those benefits flowing down to disadvantaged communities, I really think you can do it. Industry, of course, it's not necessarily their primary concern. They need to make money. That's the bottom line. And we all understand that. But I do believe, and particularly with DOE investments and some prodding, you can start to highlight those opportunities that are basically co-optimizing what we need to do for energy and for climate, and also getting those benefits down to the right communities that with the renewables revolution, for example, those disadvantaged communities probably didn't really get much out of that. But I really do believe you can hit both problems squarely on.
Yeah, and I'll just add that for a few years, my research group's been working with the team that makes GCAM, which is one of the it's a US-based integrated model that feeds into the IPCC process. And our primary overarching goal has been to incorporate negative emissions technologies into that model so they're better represented when there are international conversations around how we get to net zero and other targets. And, one of our first studies really showed that the problem with a lot of carbon removal and negative emissions is that the way the modeling works today is that it pushes a lot of that to the global south. And so there are consequences to that, right? It makes food prices in the global south go up because you're using the land to do bioenergy with carbon capture, which in the models, in the model, it's totally rational, but in the real world, it's never going to happen. And so some of these trade-offs around who's emitting and how we sort of fix the climate problem is a really important topic. I'm glad that Holly Jean Buck is at DOE working on some of this stuff because she's one of the most thoughtful people I've encountered in this area. But I really, I'm an engineering professor, so I'm a technology optimist. last week I was actually down in the Republic. Before I started my PhD at Michigan, I was in the Peace Corps for 2 years, and I was in the Dominican Republic in a very poor community on the border with Haiti. And I took my kids last week. I hadn't been there in 17 years. And I took my kids to see these communities, and a lot hadn't changed, but a lot had. And one of the things was that there was power in these communities. These are subsistence farmers, and some of them had air conditioning. And I have a project with some colleagues here in chemical engineering looking at integrating carbon capture into air conditioners. And so, are there opportunities like that where we could integrate carbon removal into air conditioning units, for example, and at the same time that a lot of the world that needs it is buying air conditioners, right? And so we could meet these co-benefits that Richard was talking about. Let's think about where those intersections exist and where are there opportunities to develop new technologies, because I can tell you, just thinking back to the GCAM work we do, the technology that we have today in some sectors, like in transportation, is there. We just need, we have electric cars, we need to build more of them. But in other sectors, we don't have the technology yet, and we really need smart young engineers working on developing new approaches across a variety of different domain areas to hit our goals. Because right now we don't have a plan in a lot of industrial sectors.
I'll just add a tiny bit, just building off of what Andre said about, when you look at Kenya, for instance, there's a lot of untapped geothermal. And one way you could think about it is coupling, again, geothermal to direct air capture, where could be, you look at a country like Kenya that is, just very small in terms of the responsibility of the emissions that are in the, that we're putting in the atmosphere. And so they would easily, quickly, with very little direct air capture, be able to, get to net zero, ultimately, because their emissions are so low. And so you could imagine that if there was an investment there of direct air capture, recognizing there's value there to kind of offset others that are more emitting. And they also have the basalt formations like you see in Iceland with Carbfix. So there's good synergy there. But you have this co-benefit of actually bringing electricity through advancing geothermal to communities that don't have access today. So even though you might start with direct air capture, that direct air capture in that kind of voluntary market that we're starting to see today could help to enable broader electricity production, for instance. And so I think there is a way to look at some of these co-benefits of carbon removal in different regions.
Okay, excellent. Yeah, so I think that there was a question in the pre-submitted chat based on can carbon capture be done anywhere? But I think we touched on that a little bit. If anyone has anything to add on that, maybe talking about the barriers to entry or wants to comment on that, you can go ahead. If not, we can start to close up the discussion.
I was just going to jump in with one comment, and it was actually to that previous question that you just brought up, Jack, about can it be done anywhere? And it kind of relates to what I was talking about before about not companies quite being left behind, or the needs for phase one. One of the concepts that we've thought about, and there's a paper that Andres and I have from 10 years ago called CO2 deserts, and we talked a couple of months ago, starting to think of this concept. It's just we don't have a project for this, we don't have a proposal, it's just an idea. But this idea of carbon deserts, and the idea is there's a lot of low-hanging fruit out there that's just going. It's the government incentives are there. You've got 45Q at $85 a ton. People are doing it, probably in the Gulf Coast, maybe some places in the Mount Simon. There's other places they're going for it. And those low-hanging fruit possibilities, I don't know what the number is, but let's just say you can get to the first few 100 million tons a year with current subsidies. You don't need anything else. It's going. Carbon deserts in our mind are places that don't have ready carbon storage, or the industry in that area is a bit left behind. The idea is these carbon deserts, we need these carbon deserts to kind of be filled if you want to get to the gigaton level. So we've done the low-hanging fruit is just going, it's going gangbusters, it's great. But if we want to get to those real 2050 targets, we're trying to flesh it out now. This concept of carbon desert, I think that's where the government still has a role to try and fill those and it could be states that their data is just not good enough right now for industry to say to jump in, let's do it. So where we are today, where I am in Michigan, we might argue that's a carbon desert. It's got great storage opportunities, great capture opportunities, but it's not really happening. It's just not a high profile thing. So anyway, I just kind of wanted to bring that up. It's related to a previous question that they talked about.
Okay, great. Any other closing remarks from any of the panelists? Well, thank you all very much for participating in this discussion. Thank you all for attending. Please let us know what you thought about this event by responding to the short survey that is in the link here on the chat. And also visit the service to society.org to take a look at more of our strategic directions for the CE department. And also look at the CE LinkedIn page for more information about some of the work we're doing here. But with that, I guess I'll thank you all again for a great seminar and a great discussion, and hope to see you all soon.